In this video, we are going to do another example where we convert a statement in words to logical symbols. So the statement is, some student has never been asked a question by a faculty member. And the framework is, let S of X be X is a student, A of X comma Y will be X has asked Y a question, and F of X will be X is a faculty member. The domain of all variables is people at SCU. Okay, so I want to get this started by breaking down this statement and rewriting it in a way that really makes it clear where the quantifiers are. So I see that it mentions some student at the start. So that suggests I use a there is quantifier. What I would say is there is, I can't say there is a student because the domain of our variables is people. So what I can say then is there is a person. There is a person, and when I use a quantifier, I have to introduce a variable to go with it. So I'll call it X. There is a person X, such that, and now there's two things that I need to assert about this some person out there. First, I need to assert that they're a student. So I'll number this 1 such that I need X to be a student. X is a student. That has to be happening. They got to be a student. And so there's going to be a key connecting word, and there's something else that needs to happen. The other thing that has to happen is, well, they need to never have been asked a question by a faculty member. Another way to say that is, any faculty member who's out there will not have asked this person X a question. So that is suggesting I'm going to use the for all quantifier for any faculty member. So this is going to be my second part of this and statement. So what I would say is for any or for all, and I need a variable to go with this for all. I don't want to use X because that would be assuming that they're the same. So I can say for all Y. Sorry, I should say what Y is. Y is, in this case, a person, SU. For all people, Y. I can't jump to saying that they're a faculty member just yet because the domain of my variables is people at SCU. It's not necessarily students or faculty specific. So somehow later I'll have to claim something about, Y being a faculty member. So for all people Y, comma. Okay, and now I need to somehow say, okay, yeah, when Y is a faculty member, they will not have asked person X a question. Well, that's kind of suggesting I use an if-then format, right? Like if Y is a faculty member, they will not have asked X a question. So if Y is a faculty member, then Y has not asked X a question. Oh, I forgot the E there. For not asked X a question. Okay. All right, so I think I'm ready to start to write this using my quantifiers. So X is a student. Well, that would be just S of X. And then the next part for all people Y, that would be for all Y. And then after the for all Y, then I'll put a parentheses, and then I have an if-then setup. So I'll put my implication arrow. And the if part is Y is a faculty member. So that would be capital F of Y. Capital F of Y. If Y is a faculty member, then Y has not asked X a question. So I have this propositional function for X has asked Y a question. I want to say Y has not asked X a question. So I need a negation. And I got to be switching the Y and the X. I'm switching who's asking the question. So it's the negation of Y first. Y hasn't not asked X a question. Okay, so we're ready to put this all together. So first we have this, there exists. So there exists a person X such that all of this is happening. So I'm going to put a big old bracket. And the first part of my AND statement, I'm going to use my AND operator, is S of X. And the second part of my AND statement was all of this. So the second part was for all Y if f of y, if y is a faculty member, then that implies it's not the case that y has asked x a question. And we got it. We got our symbol in logical, we got our statement in logical symbols now. And I want to briefly talk about, well, why is this not just the following? Like, why couldn't I just move this for all y in front here and write it like this? Well, just kind of thinking about this intuitively, in this first setup, we're saying we have this and statement inside. And for an and statement to be true, I need this part and this part to both be true. Both parts have to happen. So this is saying X is a student, that has to happen, and this other part about, when Y is a faculty member, they won't have asked X a question, that has to happen. But in this one, we have this if-then setup, where this is the if part, this is the then part, and in if-then part, this part, the if part does not necessarily have to happen for it to be true. And that's already a drastic difference between what they mean. Okay, if I really want to break it down more precisely, I have this there exists X here, and there's a way I can pick an X value that's going to make this if part be false. Because if I think about the S of X part, that's saying X is a student. But what if X is not a student? What if X is not a student, which could happen? What if X is not a student? Well, if X is not a student, that would mean this S of X part is false. And if that's false, that would make the and statement false. That means the if part of this if-then statement is false, which automatically makes the whole if-then statement true. Okay, so regardless of what y is at this point, we've established that this whole if-then statement is true. So it's definitely going to be true for all y, because it's true no matter what y is. So the whole thing is automatically true. Whole thing is automatically true. But that doesn't make sense here. The whole thing is automatically true because this sentence, depending on, who the students are, who the faculty members are, who's asked who a question, this could be true. It might not be. But this way of writing it is making the whole thing automatically be true, which doesn't make sense.